Let us see how to define a simulation scenario on an example to illustrate a process model that is not block structured. There is in here a loop that has multiple exit points, and therefore cycle time is not directly applicable. To define a simulation scenario on this process model, we first define the processing time of each activity in the process. Remember, the processing time is the time it actually takes to perform the activity. In some cases, it is possible that the processing time of an activity is fixed, but this is very rare. More generally, the processing time of an activity can vary, and simulation allows me to take this into account. Any simulation engine will allow me to define the processing time of an activity by means of a probability distribution. Two very common probability distributions for processing times are the exponential distribution, which has this characteristic that many process instances have a processing time between or around a given mean value, but some activities, executions can take much more time. Or another distribution that is typically used in the context of simulation is the normal distribution. And the normal distribution is a symmetric distribution where the values vary around the mean in both directions symmetrically, according to a given standard deviation that tells you how much variation is observed. So we can define the processing time of an activity for the purpose of simulation using a fixed value, but this is very rare. It is used in some cases where, for example, an activity is performed automatically by a system, and the system does it in a very predictable way and therefore takes a very predictable amount of time, and the processing time varies very little. More commonly, the processing time of an activity could follow a normal distribution, which is the case, for example, in the context of activities that are very repetitive, where there is a very well-defined script, in which case the activity is expected to take its mean values, but sometimes for some reasons it takes less, sometimes it takes more in a symmetric way. For example, checks in a business process, like check the completeness of an application, is an example of an activity that could follow a normal distribution. In general, checking the completeness of application takes a certain amount of time. Sometimes, due to some small deviations, small errors, it might take a little bit more or a little bit less time. Finally, the third common type of distribution is the exponential, and that one is used, for example, in the context of activities that have complex decisions or complex analysis on them. For example, assessing an application. Sometimes there are some simple applications where the assessment is routine and doesn't take too much time, but in some cases the applications might be very problematic and there may be a small number of them and they take much more time than the mean, and therefore an exponential distribution might suit better than a normal distribution. There are other types of distributions, and there are statistical packages that will allow you, if you have data about some processing times of different executions of an activity, for example, to determine which probability distribution fits better with respect to the observed data. In our example, we will assume that check credit history and check income sources follow a normal distribution with a mean of 10 minutes and a standard deviation of 2 minutes. We will then assume that assessing the application, which is a complex decision-making task, follows an exponential distribution with a mean of 20 minutes, which means most executions will take between a few minutes and say 20-25 minutes, but some executions might even take hours. And finally, the make credit offer and notify rejection follow a normal distribution with a mean of 10 minutes plus minus 2 minutes of standard deviation, and receiving the customer feedback, we will assume that it is an instantaneous task performed by the system, which just receives an email, and therefore we will say it takes almost no time.